All right, so we're on 4.3, graphs of tangent and cotangent functions. This is a quick mate video, well, notes and video, because for some reason, somehow, I lost my original 4.3 notes. So we're rolling with the one that I made this morning, okay? So graphs of tangent and cotangent functions. So do you remember how we paired sine and cosine together? Well, that's how the graphs are modeled. So sine and cosine have similar attributes, processes, and everything. That's going to be the same for tangent and cotangent, and we're going to talk about those similarities. Okay, so we're going to go through the graph of tangent function and graph of cotangent function, and then we're going to talk about techniques for graphing and connecting graphs with equations. So tangent is unique because tangent has undefined points, right? Because tangent has undefined points, that means that there are vertical asymptotes in the graph. Okay. And we're going to look at where these asymptotes exist and keep going from there. So here's the tangent function. Tangent function is tan x. The domain of the tangent is not a continuous domain, and that's because of the asymptotes. Your asymptotes happen at 2n plus 1. Remember, 2n plus 1 means odd number. So every odd half is where you were going to have your asymptote. So that's at 1.5, 3 halves, 5 halves, 7 halves, 9 halves, and then also their negative versions, okay? So our key points for our tangent function are listed right here. So these are your parent function points. So these are the points that we're transforming throughout. So we start at negative pi over 2 to pi over 2. So instead of starting at 0, we start at negative pi over 2 and pi over 2. Okay. If you look here, you can see that our other 3 points are our actual points that we can manipulate, which is at negative pi over 4 and positive pi over 4. When you're looking at negative pi over 4, think of it, okay, I'm going clockwise on the unit circle, so that puts me in the fourth quadrant at 315, right? So you're looking at 315, which means that if I'm in the fourth quadrant, that tan has to be negative, which is why it's a negative 1, okay? The tangent of 0 is going to be 0 because 0 over 1 is still 0. And the tangent at pi over 4, which is square root of 2 over square root of 2, is just 1, right? Square root of 2 over 2 divided by square root of 2 over 2. Let me say that correctly. And that's just 1. So you're still utilizing your unit circle as your key parent function, okay? And yeah, keep going. So when you have this function, again, you have it's discontinuous because of the vertical asymptotes. Your x-intercepts are on the pi's. So at 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, that's what your x-intercepts are. And that makes sense because when you go around the unit circle at 0, the tan of 0 is 0. The tan at pi is 0. The tan at 2 pi is 0. Okay, so it's all based off the unit circle. All right, its period is pi, and that's because it only takes 1 pi for that pattern to continue, right? So from 0 to 180, I'm gonna go through the whole ring of 0, asymptote 0, right? So it only took me 1 pi to repeat the pattern. Does that make sense? Which is why your period is pi. There's no amplitude. The reason why there's no amplitude is because there's no max or min to find the distance to a midline. So therefore, there's no amplitude. You will still have a vertical stretch, but there's no amplitude. Okay. The graph is symmetric with respect to the origin, so it has rotational symmetry. All right. So my rotational symmetry means that I can rotate it 180 degrees about the origin, and it will still look the same as long as it's going through the origin, like so. And that makes sense because that's where the value lies. Now, cotangent. Cotangent is our opposite, our reciprocal. Okay. Cotangent is the reciprocal. With cotangent, so on tangent, your domain and your asymptotes, right? Your asymptotes, your x-intercepts are all based off the pi. They switch for cotangent. Okay. So for cotangent, your domain is where your tangent equals 0. That's because now it's in the denominator, right? The variable's now in the denominator, and you're not allowed to have 0 in the denominator. Cotangent starts at 0. So if you look at our key points for cotangent, it's from 0 to pi. So we have 0, pi over 4, pi over 2, 3 pi over 4, and pi. So we're still only in that top half of our unit circle and evaluating the quarters in our top half. Okay. And we're at 1, 0, -1. That's what alters on the inside. Okay. So now, because it's the reciprocal of tangent, your vertical asymptotes are at in pi. So 0 pi, 1 pi, 2 pi, 3 pi. Your x-intercepts are now at odd halves of pi. So at odd halves of pi is where your x-intercepts are. And its period is still pi because it's still going to repeat that same cycle only after one period. There's no max, no min, so there's no amplitude. And the graph is symmetric with respect to the origin. So it also has origin symmetry. Okay. The way I remember this, think of, do y'all remember the cubic function? The cubic function kind of does the same motion. It just doesn't have asymptote. All right, so tangent and cotangent functions can be graphed directly with a graphing calculator. Just remember that cotangent isn't on the calculator. So in order to graph cotangent, you have to either graph it as cotangent of x equals 1 over tan x, or cotangent of x equals cosine x over sine x. You're rarely going to find a calculator that doesn't have tan on it. Okay, so the second one isn't necessary. But in case you do, for whatever reason, pick up a scientific calculator, it doesn't have tan, it is a-okay because they can all be represented using sine and cosine. Okay. Cool. All right. So I thought I deleted the writing. Okay, we're just gonna pretend that we don't see the writing yet, and we're gonna just make our way through it. All right, determine the period. So when you're graphing cotangent, the first thing you want to do is determine your period. Your period is pi over b because it only takes 1 pi for the pattern to repeat. So it's period equals pi over b. Your vertical asymptotes, solve the following equations for. So when you're trying to figure out where your vertical asymptotes are, you are starting with negative pi over 2 and ending at pi over 2. So you can kind of set it up as a joint inequality if it helps. As a joint equality, it's not mathematically correct, but as you can see, either way, I'm going to be doing the same thing to both sides, right? And they're not going to be equal. I should have put less than, yeah, let me do this little number, even though it's not 100% accurate. All right. And then once you have that, you keep going. Now for cotangent, instead of being between negative pi over 2 and pi over 2, it is between 0 and pi. So you're going to take your argument on the inside of your trig function, your trig function, and you're going to solve it between 0 and pi. So with sine and cosine, we were between 0 and 2 pi, right? And now for tangent and cotangent, theirs aren't the same, but the process is. Step 2 is to sketch 2 vertical asymptotes found in step 1. So now I have my vertical asymptotes. I'm going to draw my vertical asymptotes. And then step 3 is just like before, divide into 4 equal parts. So I'm going to find the midpoint between each one, and then find the midpoint between the next two, and then find the midpoint between the next two. Step 4 is to evaluate the function for the first quarter point, midpoint, and third quarter point. Step 5 is the points with the smooth curve you're going to connect, and then the rest are just going to indicate that they are asked. Okay, so let's graph our first tan function. So up first, we have tan of 2x. So tan of 2x means that we have a vertical compression, I mean a horizontal compression, right? So our period is going to be affected. Does that make sense? So we're compressing horizontally, so our period is going to be affected, okay? So we set it up so that we can figure out where are our asymptotes. So we normally start at negative pi over 2, and we start at pi over 2. We're going to divide both by 2. When I divide both by 2, I now know that my vertical asymptotes are at negative pi over 4 and at positive pi over. Okay? Okay. Step 2 is to sketch the vertical asymptotes. Bam, here are my vertical asymptotes. After I sketched my vertical asymptotes, I'm going to divide it into 4 quarters. What are my quarters? What's halfway between 0 and pi over 4? Pi over 8. It's 1/8. 1/8 pi. And so then it's going to be positive 1/8 pi and negative 1/8 pi. So
okay, yeah, I thought I was stupid.
No, you just had to think about it. Okay. So we end up with negative pi over 8 and 0 pi over 8. Now, is there anything changing my y's, my output? my outputs aren't changing. So my output's going to remain being -1, 0, and 1. Because nothing changed the output. It was only that affected. Okay? How do you feel?
All right.
It's not that much different. It's not that much different from sine and cosine.
It's on it.
It's a little easier. I
Especially when
agree.
you get to the graphs, it's so much easier.
Yes. Okay, so this would be your completed graph. The other two are just parts of another cycle. So questions, comments, concerns. All right, next we're going to do a tan example. But with this tan example, we now have a vertical stretch and a reflection, right? We have a reflection over the x-axis, a vertical stretch, and this time we have a horizontal stretch instead of a horizontal compression. Because x's are liars, so when it looks like a half, it's actually not. So, reason being here, we now have pi divided by half, which means our period is 2 pi long. So it's taking it a little longer to repeat the pattern, right? And then this was a typo, I put the plus there. Now we have 2b equals 2 pi and 2b equals -2 pi, which means that our x's are at, our asymptotes are at positive pi and negative pi. Okay, then we're going to divide in half, and that's fairly easy to divide in half. Pi divided in half is pi over 2. And then its opposite is going to be -pi over 2. Okay, this time, however, there is a change to our y-axis, right? So our y values that used to be negative, it used to be 1, 0, I'm sorry, -1, 0, and 1. What am I doing to each y value? I'm multiplying them by -3. So to each one of my y values, I multiply by -3. So this used to be a -1, this was a 0, and this was a +1. And after multiplying each one by -3, and that's how we get the easy, right? Okay. So here's our beautiful graph.
Yeah, it reflects, right?
Yep, and it was reflected over the x-axis. Okay.
Like,
All right, cotangent example. I'm going to keep going. This is just reiterating what we said about it being vertically stretched and that it's our A value and A is negative, so that's why. Don't need those notes. Next is our cotangent. Our cotangent here, this time, we have a vertical compression and a horizontal compression, right? So we're compressing vertically and horizontally. So our period here, this time, is pi over 2. Okay, so our period is pi over 2. And now we got to find our halfway point. So it's halfway between 0 and pi over 2. Pi over 4. And then halfway between 0 and pi over 4. Pi over 8. Halfway between pi over 4.5. Ooh. Dun, 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 dun. What's 3 pi over 4 divided by 2?
yeah.
That means 3/8.
Yeah.
3/8. Okay?
I thought,
Yeah.
I said 4 over 8, but it's 3.
It would have been 3/8. All right, so we end up now having our x's. So remember, for our x's, they are normally 1, 0, and -1, because cotangent, you're decreasing. Okay, tangent, you're increasing. So tangent was -1, 0, 1. Cotangent is 1, 0, -1. And to each one of these values, I'm going to multiply by 1/2. And that's because my vertical compression is 1/2. So once I multiply each one by 1/2, my new points are bam. I know, crazy, right? It just sounds easier because you guys have been learning.
No.
All right, so putting it all together here, remembering that tan is from -pi over 2 to pi over 2. Cotangent is from 0 to pi. That's where our asymptotes are, right? It's not from there. It's just those are our boundary lines to let us know where we're starting our pattern. For y's for tangent, they start off as undefined, -1, 0, 1, undefined. For y's of cotangent, they start off as undefined, 1, 0, -1, and undefined. That's why this is an increasing function and this is a decreasing function. And so that's how we end up with our cotangent. And then putting it all together, we're going to make a table of it just side by side so you can compare. So we're going to start off with tan of x, your x's, and your y's. So our first x is at what? Just said it. Is at negative pi over 2. And at negative pi over 2, it's undefined. Okay, our next x is at negative pi over 4. And what's the y value here? Negative 1. Then we're at 0. And what's the y value?
Same thing.
Now we're at pi over 4. That's 4. 1. And now we're at undefined. Okay. All right. Now let's do it for cotangent, making sure we can put it all together. I was like, guys, we were just killing it. What happened? Okay. So now for cotangent of x, we're going to make its table. So it's x's and it's y's. Okay. Our first x here is what? It's 0, guys.
Yeah, 0.
Cotangent starts at 0. Okay. Cotangent starts at 0. How you remember this is that where do you have a 0 on tangent? In the middle. So that for when you do the reciprocal, it's going to become a asymptote. It's going to become undefined. Okay. So we have 0. After 0, we then have what?
Yeah.
Pi over 4. At pi over 4, we are 1. There we go. Then halfway, pi over 2, we're at 0. At 3 pi over 4, we're at negative 1. And then we end at pi, which is undefined. Okay.
We were killing it, but then the
All right. So do we see the differences in some way to try to remember the
yes,
two? Okay. So your zeros for your tangent are your undefined for your cotangent and vice versa. Okay. And that's because remember that tangent equals y over x and cotangent equals x over y. So now my denominators are changing, right? And that's why it ends up being the opposites. Cool. All right. Let's go backwards in a minute. So this one, this one is pretty straightforward. Notice that there isn't a vertical or horizontal stretch, but there is a vertical translation, right? There's a vertical translation, just simply means that yes, you can vertically translate even though there's asymptotes, okay? All I'm doing is changing the values of my y. So each one of these y values for tangent, I'm just adding to them. That's it. So I'm adding 2 to them, and it's going to shift it up. That's all.
Yeah.
Okay. Vertical translation. Cool.
Yeah.
All right. You can even look at it as a graph, but you can see how all it did was shift from the parent function. Okay. Now, let's describe what's taking place here. Tell me all the changes.
Phase shift.
There's a phase shift. It goes down. Phase shift which way?
To the right.
A phase shift to the right.
Down 2
and overflex what?
Uh,
Over the x-axis. Okay. Lies. Your algebra 2 teacher. Nice try.
Nah, she was never here.
Lies. All lies. Ignore them. All right. Period here is pi. And the reason why the period didn't change is because there was no b, right? Yep. There is no b value of no visible b. It's always cast with a friendly line. Okay. Like you said, we were reflected. So we're going to be reflected over the x-axis. Perfect. There's a phase shift of pi over 4, which is going to the right. And then we had our graph was translated down to units. Oh my gosh, y'all did perfect. So proud of you. Okay. All right. So to actually draw it, you're first going to always locate your asymptote because this is cotangent. Cotangent starts at 0 and ends at pi. So you're taking your argument and setting it equal to 0 and setting it equal to pi. And then once you find it, then those are your asymptotes. So my first asymptote is going to start at pi over 4, and my second one's going to start at 5 pi over 4. After I do that, then I have to do what? Huh? Say it again. So here, all you're doing is getting x by itself.
No, yeah.
Oh.
I'm talking about the 5 power 4. Like, I can see why we got it, but like also.
Remember chopsticks. So you have pi over 1 plus pi over 4. Is you 4 pi plus 1 pi all over 4.
Okay, yeah. Just making sure.
Yes. So you get your 5 pi over 4. Good? Yeah. Perfect. Now we're going to do our points. So remember, we're finding our midpoint, our halfway point. So we're adding, dividing by 2. That's our first one. So on the first one, we're adding what is 1 pi plus 5 pi. 6 pi over 4 divided by 2 is what? 6 pi over 4 divided by 2 means it's going to be 1/2, which is a 6 pi over 8. So our halfway point is at 3 pi over 4. And then you'll do it again. So now you have 3 pi plus 1 pi, which is 4 pi over 4. And 4 pi over 4 is just what? Pi. Perfect. Then we'll do it the other way. So 3 pi plus 5 pi is 8 pi. 8 pi divided by 4 is 8 divided by 4, guys. Don't embarrass us. It's 2. So here are our points. I was like, what? What are we doing? Why aren't y'all saying the words that need to be said? Embarrassing. No, I'm playing. So we divide. Easy enough? Anyone like, oh, I can do that? Sure.
I'm gonna speak for Lily and say that I won't do this.
Oh, I don't want to do this. Yeah, that sounds about right. How did I get -3, -2, and 1? -1.
Oh, well, going down to, you have to subtract 2 from whichever ones it was, and since it's cotangent,
yep,
it'd be 1, 0, -1.
There we go. And so we subtracted, right?
Right.
And then we had to multiply each one by what? We had to multiply and then subtract 2. Okay. So in order of what took place, we had to, this used to be 1, 0, and -1. We multiplied each one by a negative, and then we subtracted 2. Make sense?
-1.
And that's how we ended up with our new y values.
Oh, yeah.
Got it? Okay. All right. So then once we put it all together, there we go. We're geniuses. We knew it. We did it all along. We did it by ourselves. Okay. Now, can we go backwards?
Yes.
I believe we can too. All right. So the first thing we want to do when we're going backwards is to decide if it's tangent or cotangent. Look at the asymptote. It'll be tangent.
Yeah.
Because there we go. Okay. It's a tangent that has been reflected. And what else?
And it's also been, has it? Yes.
Then what?
Did we, oh,
okay.
My bad. I won't talk anymore. Again.
It's been what?
Yes, right.
It's been vertically stretched, right?
That's what I was gonna say.
It's been vertically stretched. So we've been reflected and vertically stretched, and that is it, right? Our period is still from -pi/2 to pi/2. None of that changed. So putting it all together.
Yeah. So
-2, -2 tan x. Make sense? All the things we said was happening. Okay.
Thing that the whole was easy about, like,
what about this one?
Well, we're still at power 2, but we're starting at 0.
We're starting at 0, so we're gonna do it as what? Cotangent, and we did what? Yeah, and we went down. And anything else?
the period is changes now.
Yeah. How did my period change? It wasn't shift.
Isn't it value is compressed?
All right. It wasn't compressed. Was it compressed? Yes, compressed.
Yeah.
It was compressed. It used to be pi. Now it's pi over 2. So does that make sense? So from here, we know that our D has to equal -1 because it went down 1, right? We know that our B has to be 2 because it was horizontally compressed. And our period, exactly. So therefore, putting it all together, we establish that this is tan or cotangent. Which one? This is cotangent. Okay, it's cotangent because our asymptote is beginning at 0. So we end up with everything in place. So we get y is
Look at like that. Throws me off. Why can't it just be cotangent 2x?
because they don't use
Yeah, they don't
parentheses.
use the parentheses. It's just like it
I
looks
know.
wrong.
If it bothers you, you got to use the parentheses and move it. Okay, but without parentheses, then your D has to be in the front
That doesn't bother you
at this point now.
at this point.
Yeah. All right. So remember how we talked about sine and cosine can be interchanged? That's the same for tan and cotangent. But imagine that one that we just did. We did it pretty simple and straightforward. However, it can also be represented as a negative cotangent by based off a negative compression and then based off still going down 1. Do we see that? It could be also represented as a negative tan function, but in order to be a negative tan, I also need a phase shift. Okay, because that means I'm now looking at it from a different perspective. Does that make sense? So they all go together. However, why would I make it harder?
Yeah.
Why would I make it harder? Yes. Why make it harder? Okay. Don't do that to yourself. All right. And that is 4.3.
Oh yeah. You need to focus on.